Hello everybody. Do you have a craze to learn the basics and details of engineering? If so, you are at the right place over here. Here I'll be dealing with the initial and the basic subjects like physics, chemistry, mathematics, communication techniques, and along with that we'll go to the detail and deep study of electrical, mechanical and civil engineering. Here you will find videos related to all of the trades of engineering including agriculture engineering. We'll have a deep dive into the various world of engineering right from the basics of civil, electrical, mechanical, agricultural engineering. You can also suggest your related video and the topics of your concerns. So I'll be taking them up very seriously and you'll be provided with a video sooner or later. Here in this video, we are going to deal with the communication tower foundation that are designed for safety purposes, and we'll ensure that the stability and prevent overturning settlement. The key consideration into account are the soil conditions, the wind load and the type of towers that we are going to be using. The design, which involves the geotechnical investigation, finite element analysis, and adherence to relevant codes like ANSI, TIA, and ACI. So let's begin with the video right away. Here I have used, so here we begin with the communication towers and the foundation needs for building up a communication tower.
When it comes to communication towers, stability doesn't start at the top, it begins deep underground. I'm taking you on a fast-paced deep dive into the engineering behind communication tower foundations, and why every detail matters. So let's start from the ground up. The first step, geotechnical investigation. This means digging into the soil, literally. I examine the soil's bearing capacity, shear strength, and compressibility. If the ground can't hold the load, that's a problem. I also check the groundwater table because a high water table can weaken foundations or cause uplift. And don't forget seismic zones. Knowing if the site is earthquake prone shapes the whole design. Next up, foundation types. If the soil is strong, I can use spread footings, a broad shallow base that spreads the load. Weak soil, I go for pile foundations. These are long, deep columns that transfer the load to stronger soil layers far below. For monopole towers, I might use a single, massive monopile. Choosing the right foundation type is all about matching the site's needs. Now let's talk loads. Wind is a major factor. Those towers face serious pressure from storms. I calculate wind loads based on tower shape, height, and exposure. Dead loads come from the tower itself, plus antennas, cables, and equipment. In seismic regions, earthquake loads need to be factored in. And don't overlook uplift forces. Wind can actually try to pull the foundation up. The way the foundation and soil interact also affects how the load gets transferred and how much the structure settles over time. But none of this matters without code compliance. I stick to ANSI TA standards for structural integrity and ACI for concrete design. That way I'm not just building strong but building safe. For design and analysis, I lean on advanced software. Think ASM Tower or Bentley Open Tower Designer. These tools help me create a detailed model, apply all possible load combinations, and see how the structure will behave under real-world conditions. I run structural analyses to check for stress, strain, and deflection. Here's where things get technical: reinforcement design. I design the steel bars, rebars inside the foundation to resist tension and shear. Their size, spacing, and placement are critical. Get it wrong and the whole foundation could fail. Then I check for stability against overturning, sliding, and uplift. Only when every safety box is ticked do I prepare detailed construction drawings with exact dimensions and specs for every element. Why does all this matter? A solid foundation is what keeps communication towers standing safe, reliable, and long-lasting, no matter what nature throws at them. Let's wrap up. I start with thorough geotechnical investigation. I pick the best foundation type for the site. I count for all loads: wind, seismic, dead, uplift. I use powerful analysis software, design reinforcement in detail, and stick to strict standards. The result? Towers that stand tall for decades. If you want to learn more about smart engineering solutions, hit subscribe, like, and share. Thanks for watching. See you in the next deep